Hello everyone, welcome to Mr. Naylor's class. I'm Mr. Naylor, and today what we're going to do is we're going to add and subtract radicals. Now just as a review, I got some perfect squares up here. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, and so on. Now the square root of 1 is 1, the square root of 4 is 2, the square root of 9 is 3, the square root of 16 is 4, and so on. A little bit of review of perfect squares. Now, for us to be able to add or subtract radicals, they have to be like terms. Now, what do I mean by that? I mean that if we have 2 times the square root of 3 plus 5 times the square root of 3, that these two numbers in the radical have to be the same for us to be able to add or subtract them. If they are, we add the two coefficients. The coefficients are the numbers in front of the radical. So 2 plus 5 is 7 times the square root of 3. We leave the 3 the same. If I have something like 5 times the square root of 7 plus the square root of 7. Here there's no coefficient. Now we're not going to put a 0 there. We are going to put the number 1 there. And we're going to add the 5 and the 1. 5 plus 1 is 6 times the square root of, we're going to leave the square root of 7 the same, 6 times the square root of 7. If we have something like 6 times the square root of 11 minus 6 times the square root of 11, to be able to add or subtract them, they have to have the same radical, and they do, so we can subtract. Now, 6 minus 6 is 0. 0 times the square root of 11. 0 times anything is 0, so we're not going to leave the answer like this. The answer to this one is 0. Now, let's make this a little bit more complicated. Let's say we have 3 terms. We have 11 times the square root of 7 plus 8 times the square root of 3 plus 9 times the square root of 7. Here the 7 and the 7 are the same, so we can add those two like terms. 11 plus 9 is 20. So I'm going to put 20 times the square root of these 7. Now 8 times the square root of 3 is not a like term, so we're just going to rewrite it. So plus 8 times the square root of 3. Now to make this even more complicated, let's say now that we have inside of a radical symbol, let's say we have 5 times the square root of 3 plus 2 times the square root of 27. Now we have different numbers inside the radical symbol. I can't add them. However, I can simplify the square root of 27. What times what is 27? 9 times 3. So I'm going to put 5 times the square root of 3 again, plus 2. 27 is 9 times 3. 9 is a perfect square. So I'm going to rewrite again, 5 times the square root of 3 plus 2 times square root of 9 is 3. And then I'm going to keep this 3 on the inside. Now I'm going to multiply these two numbers. 6 times the square root of 3. Now they're like terms, square root of 3 and square root of 3. Now I can add or subtract the two numbers that are on the outside, the coefficients. 5 plus 6 is 11 times the square root of 3. Now, I want you to try one. let's say 12 times the square root of 5 minus 2 times the square root of, let's say, let's change this 5 to a 2, and let's put a 50 here. So a lot of times, we got our 2 right here. This could give us an indication of what this number is right here. So go ahead and try this problem. I'm going to try it too. Let's see if we get the same answer. All right, let's see if we got the same answer. Is 25 times 2. 25 is a perfect square. Square root of 25 is 5. I brought the 25 out. Square root of 25 is 5. 2 times 5 is 10. Twelve minus 10 is 2 times the square root of 2. Thanks for watching the video. Please like and subscribe and hit the notification bell so you never miss another video, and I'll see you in the next one.